Good evening to everyone. In our today's video, we are going to see the Armstrong number. So already we discussed this Armstrong number in our previous video. So kindly check the previous video for a better understanding. So in our previous video, we just write a code. To evaluate for three digits. So let me check once. So I just taken a variable, I just taken a value from the user. I just store this value in a buffer, that is a temp. I just check up to this n value becomes zero. The condition should be run. If it is an n equals to zero, the condition should be the stop. That is the condition. If n equals to zero, it should be zero. Until if it is in not equals to zero, it should be run the while should be run. Okay. So there I just take the reminder as well as the coefficient. The reminder will be stored in R variable, and default I just store the I send the value of sum as 0. So for the 3-digit number, it should be cube of. Okay. So first digit cube, second digit cube, and third digit cube summation should be equals to my given value. So for the second iteration, the coefficient value becomes the real value. The coefficient value becomes the real number. So n equals to n by 10. So now in the second iteration, n will be my coefficient. Okay. So once whenever n equals to 0, the condition will be stops and the while loop will be exits. From there, it should verify your temporary variable and your summation should be equal or not. If it is an equal, you can get the answer as your Armstrong. If it is not equal, we can say that the given value is not an Armstrong number. That's it. So here, this is the code for 3-digit number. If I want for this 4-digit number, we are modifying here it as R power 4. But now the condition, that means in our previous video, we considered the condition, whatever the number, as per the user wish, because if you go to the ATM, they won't specify only draw the 1,000 or only draw the 500, they won't specify. We give the number. If the notes are available, they give the amount. They deduct the amount. If notes are not available or required some sufficient amount is not there, they just simply choose another value. Likewise, we also need to provide. So here we will. Okay. So kindly check once. So for that, how to modify? The giving the taking the values from the user, we are not modifying. We just saying that enter the values. So taking the values from the user, it's no need to modify. I just keep it as an as it is. Now storing the your number into a buffer. That's fine because we need to verify here with this buffer. Next, how many times? That means this R power should be run how many times? Kindly check once. We will think once. For example, if it is in 153, which is having the length, that means that total number of variables, the total number of digits is 3. So that's why the value power will be equals to 3. For example, if it is in 134, that means 1534. If this is the value, the 1 power should be changes as 1 power 4. That means the value of index, this is 1, 2, 3. This is the index value becomes 3. This index 1, 2, 3, 4. This becomes 1 power 4. So based upon the total digits, this R power will be varying. Okay. So first of all, The first condition is you need to find out what will be the number of digits. Number of digits. This number of digits, how you can able to find out? For example, if I'm considering this 153, for example, if I'm divide with 10, if I divide with 10, in first iteration, the remainder equals to 3. The remainder equals to 3. And the coefficient value will be 15. The coefficient value will be 15. Likewise, in the second iteration, this will be my given value. This will be my given value. That means the given number is 15. Here, remainder is 3. Oh, sorry. Here the remainder is 5. And the coefficient is 1. Coefficient is 1. So now it becomes my given value. So coefficient is 1. Remainder is 1. So remainder is 1. And my quotient equals to 0. Quotient equals to 0. For fourth iteration, if it goes fourth iteration, the n value becomes 0. So when I check my condition, whenever n equals to 0, it should be goes out. So now, if you observe how many iterations it is happened. This is the first iteration, this is the second, and this is the third. When it reaches the fourth iteration, it goes in, it is not going inside the loop. It is not going inside the loop, it just exits the loop. So with that, we can write in a code. Okay, we can write a code. So I'm just copying the logic previously because I'm okay. So in this logic, instead of getting summation, first of all, my interest is I need to find out what will be the length of your numerical. So I need to calculate what will be the iteration count. So I just find out I equals to I plus 1, or you can directly give it as an plus plus I, or I plus plus, post increment or pre increment, both can be fine. So we can assign it as an I equals to 0. That means we initialize with I equals to 0. So once I find out this, I need to verify the n value. But kindly observe, once this loop is exited, can you say what is the value of your n? What is the value of your n? N becomes sorry. So we are finding the n value. Because okay, once you exited this code, what's your n value? N value will 0. So for that case, I need one more variable. Which can stores a temporary variable of your given number. I will given a numerical as variable as t1. So kindly, so I'm just assigning the variable t1 with given number. Now, in second iteration, we are verifying t1 because previously n is already becomes 0. So we are considering the t1 right now. You may ask the question, why you are not disturbing the temp also having the variable numerical of n, because if I am disturbed temp there, I can't able to that means whatever conditionalizing this, that whether the temp value, I mean the given value and my summation value are same or not, I can't able to measure. That's why I'm just taking another numerical. So verifying, because we are finding the remainder, as well as we're finding the coefficient. We are finding the remainder as well as the finding the coefficient. Here we need to modify, because this is my main program. Because if it is in 3, it is, if they're having the length 3 digits, we can say that it is a 3 r cube. If it is in 4, it should be r power 4. Now I am don't know what will be my value, so I just go for power. R, this is 1 cube, that is your base reminder as your base, reminder as your base, and the power value will be equals to your number of iterations. Power value will be equals to your number of iterations. That means R comma I we are providing. Okay, done. So we will check. So I'm reducing the spaces, then because if I reduce the spaces, all the programs, I mean all the lines of code will be in same set. Okay, so this is my code. So I just run the code. Hope no errors will be there. So I'm providing 153 as my input. So it is giving that it is an Armstrong. So next one, I think once again, it is 1634. We will check. 1634. 1634. Yes, it is giving that it is an Armstrong. So again, we will run for one more value, 1674 randomly. This is not likewise. I just give for 32, not an Armstrong. We will give one more value, that is 1. We will check. It is an Armstrong. Anyhow, 1 power 1. It is an Armstrong. Okay, no issue. That's it. I hope the logic is easily understand to you. If any issue, kindly go through once again. And better if you go through the part 1, it is easy to you to understand this. Here I'm using only one thing, that is in first logic, I find out the total number of digits, in the given number. So by using the I variable, I find out the total number of digits. In the second variable, the previous one, whatever the thing, again, the remainder, the summation, all those things. But I just initialize one more variable. That's it. Apart of that, the logic is same. Hope this will be helpful for you and you got your answer. The persons who are cracked this question, I mean program, is very well, you are fine. Those who are trying, it is very good.